All right, everybody, let's go ahead and get started. I have a new programming language called the Cobra programming language. I have a 40-minute talk, but I have 15 minutes for it, so questions are going to have to be rapid. I am Chuck Esterbrook, the author of the Cobra programming language. Yeah, I guess my name's not on there. The slides are on the website. I'm going to have to skip a few of them, and there's also other information on the website, sample programs and documentation. It's cobralanguage.com. There's a dash in there, but if you don't have a dash, it still works. And Cobra's new. It's object-oriented and imperative. It adds some features that people often do through libraries, things like unit tests and contracts and so on. It's general purpose. It targets .NET and Mono, hence I'm here. But more interestingly, why bother creating a new language? It's a lot of work. So my experience over many years is that I get bounced around a lot between different languages. So if I want clean syntax for quick coding, I use something like Python or Ruby. If I want runtime performance, I often have to exit those languages to use something else. I was spoiled by Objective-C, which allowed me to use both static and dynamic typing in the same language. And I'm a little bit jealous of the iPhone Spec Sharp guys because they have contracts and they can help you out with quality features. And then this stands for if I had to do it over again. This is what Anders mentioned on the first day. If you had to do it over again in C#, he would separate this notion of whether or not something is null versus whether it's a value type or a reference type. So I want all of these features, but you can see that in parentheses here, there's no language that hits every single bullet. Except now there is. So Cobra has clean syntax. It has good runtime performance like C#. It has both static and dynamic typing. It has the contracts and the nil tracking. And I'm going to go through some of those features here. So Cobra doesn't allow nil unless you say so. So here in this method signature, which is basically Python-style syntax, name cannot come in as null. And if you try to pass it a variable that could be null, you actually get a compiler error. You can't proceed to execution. Instead, you have to pass it a variable that's known not to be null, or you have to guard it with an if statement or something of that nature. Or if you know that because of the logic of your program, it couldn't possibly be null at that time, you can do a typecast for it. Whereas in this method signature, you can pass null. Now, the upshot of this is that now that I'm coding in Cobra, I almost never see a null reference exception at runtime. I see them at compile time. And instead of seeing them one at a time, where you get the exception, you fix it, then you go on to the next one, you fix that, then you rerun, and you go on to the next one, you can get multiple detections at compile time. You can get 5 errors that say you've got places where you're passing something that could be null to something that's never going to take it. And you can fix all 5 at once before you even execute your program. This all comes down to boosting productivity. All the features I'm showing you, it's all about how do I boost my productivity, get more work done in less time. I have too many slides, so I'm going to have to just rush through a few of them. The syntax is based on Python. It's very clean and lightweight. It's not identical, but it's very close. At the higher level, though, the class declarations match up with C# and VB. So if you want to create a library and vend it back out to C# and VB people, you can do that. Dynamic or static, a lot of languages force you to do one or the other all the time. So if you use Python and Smalltalk, you will never do static typing. And if you use Java and C#, you will never do dynamic typing. So Cobra is another language like Objective-C and Boo, and I believe Visual Basic has this, where you can use both. And so here I have something that takes integers and returns an integer, and then here I have something that takes dynamic and returns dynamic. Here I have to explicitly say dynamic for the return type, otherwise it would be void. But for the arguments, I don't have to say anything. If I leave the type off an argument, it's a dynamic variable. And there's pros and cons to both. One thing that's important to realize is that dynamic is clearly the best for the following reasons. One, it's very flexible, right? You can use it with any kind of type. It's very fast to code up. And it's less brittle. You know, if somebody's using this for integers one day, and then in the future they use it for something like floats, you don't have to do any maintenance on this method. It already works as is. So it's more reusable. But at the same time, static typing is clearly best. Because when you statically type, you get compile time detection of errors. You get multiple errors reported at once, so it's less trips to runtime. It's faster. It's often slimmer because there's no boxing. And the IntelliSense is very easy to implement. So there's pros and cons. And the idea here is to let the developer decide which way they want to lean, rather than dictating that they have to use one or the other. Performance is near identical to C#. There's some well-known examples of people using Python because it's fast to code in. and then saying, okay, I've stabilized my program, but now it doesn't run fast enough, so I'm going to re-implement it in, for example, C++. That's exactly what Yahoo did with their mail system. I'm familiar with an AI company that does their prototyping in Ruby, and when their prototype stables and they come up with a new algorithm, they hand it over to their C++ experts and say, hey, now we need this to run 1,000 times faster. Go do it from scratch now that we've prototyped it. The idea behind Cobra is to get rid of that and be able to say, here's a language that's highly productive, clean syntax, you're going to enjoy using it, and it's going to be fast enough that you're not going to feel like you have to rewrite it in something else. And one of the tricks that it uses for that is when you say something like I equals 5, that gets typed statically. In other words, it leans towards static typing within the implementation of a method. And in practice, as a long Python programmer, I haven't found that to be a problem. If you want, you can explicitly type the local as dynamic. I do that once in a blue moon, but not too often. Usually I will just use a different variable for whatever other type I'm interested in. There's a couple scripting conveniences. So just like with Python, you can say Cobra in a file, and it will compile and run it in one shot without giving you any hassles. Clean syntax is the hallmark of, I wanted to say of all scripting languages, but then I remembered Perl, Bourne shell. So it's sum in italics. If you're on Unix, you can use a pound bang line. If you're on Windows and you don't know what that means, it doesn't matter. And it has the support for dynamic binding, which is definitely a hallmark of scripting languages. Here's an example of contracts. So I have a method called node4, and it takes a name and it possibly returns a node. I say possibly because the question mark here indicates that it could return null instead of an actual node. And so I have a contract on the argument. I'm saying that it has to have a non-zero length. In other words, it doesn't make any sense to pass in a blank string. And then I'm saying that when it comes back, it will ensure that the name of the result is equal to the name that was passed in. And I threw in the two lower for case sensitivity or insensitivity. These contracts, they come straight out of Eiffel. So if you are familiar with Eiffel contracts, it's near identical to that. It works with inheritance. So if you override this method, you still inherit the contracts. There's some nice things in Eiffel, like you can refer to the old value of an argument and things like that. I don't have time to go through that in the lightning talk, but that's where the contracts come from. One possible thing in the future is to generate either SpecSharp code or what SpecSharp uses in the back end, so you can use their theorem prover with a Cobra program, because it's the same type of contracts. There's built-in support for unit tests. So some people say, well, if you have contracts, you don't need unit tests. Some people say if you need unit tests, or if you do unit tests, you don't need contracts. It reminds me of the static versus dynamic debate. And so again, I'm letting you choose if you want to use one or the other or both. So here's an example where there's a test set up for this utility method that just returns a capitalized version of a string. The motivation to have the test right there with the method, the motivations are identical to Python docstrings, right? Why do we have Python docstrings as a language feature? Because it localizes the documentation with your method. It encourages people to use it because they learn about this feature that's available to them. And it gets everybody on the same page. If I inherit your code, you use the same kind of documentation that I do and vice versa. So it's the same thing with tests. And the Python community, they have a solution where they put the tests in the doc string, but as soon as you do that, you lose syntax highlighting, you lose IntelliSense. It's just better to break it out and make it more like regular code. Cobra, by default, automatically runs these tests when you run your program, and it runs them first. And the idea is that you don't want to use a class that can't even pass its own tests. Even the Cobra compiler, which is written in Cobra, does that. So every time it launches, it's hitting those tests.
Why is that test for nil if there's not a question mark in the parameter list?
Because I didn't have time to come up with a better example. Then that's why I put the So that's very sharp. So yeah, he's right. You would actually get a compiler error here because Cobra would say, you can't take a nil. This isn't going to work. But I wanted to demonstrate this expect statement. If it doesn't get that exception, or if it gets a different one, it tells you, it throws its own exception saying I was expecting an exception, but I didn't get one. And that was written specifically to help with unit testing. So it's 2008, and it's not just Python that has this problem. Almost every language, if you take the number 0.1 and you add it 10 times, you get this bizarre number. And we know why it's bizarre, right? It's because it's floating point, binary floating point number. But it's just really bad. If you assert 1.0 equals to that, you get an error. It does not pass. So the way I approach it in Cobra is I do support both decimal and float, but I default to decimal. In other words, I pick the more accurate case. It's slower, but it's more accurate, and I think that should be the default. you should make a decision that I need more speed and I'm willing to give up accuracy for that. Couple quick notes. The compiler is implemented in Cobra. It's got your usual phases. One thing I did different is I don't generate IL, I generate C#. There's a growing number of features with successive versions of C# that aren't directly implemented by the VM anymore. And if you're generating C# instead of IL, it's extra easy to implement those features. It also helps ensure that the classes you're generating are going to be consumable by other C# and VB programmers. So that was a choice there. And faster to implement. And also, I even piggyback on some of the error checking. So like Cobra right now does not give you the error that you didn't implement all the methods of an interface. However, C# does. I bounce it back. When you see your Cobra errors, if you see 10 of them, you don't know which ones came from C# or Cobra. You don't actually care. It just all works. Over time, Cobra will need to fill in all that error checking in order to have other backends like JVM or Objective-C, for example. So I already mentioned this a couple times. You can vend your libraries out to C#. There's a couple practical aspects, though. I make sure that Cobra leans towards .NET. So if you make a list in .NET with brackets 1, 2, 3, that's a system.collections.generic list of int. It's not a Cobra list or a special thing that a C# developer is not going to be comfortable with. And also, you can embed the Cobra runtime in your library so that you can hand the DLL to the developer and they don't have to have Cobra installed. They don't have to worry about Cobra laying DLL or putting it in the GAC. And this is a pretty small embedding. It's only like 90 or 100K. I'm mostly relying on the .NET runtime, so it stays pretty small. Weaknesses. Maturity. It still has gaps and some bugs because it's a fairly new project. That's indicated by its version number, which is still less than 1.0. There's more nifty features I would like to have in the language that are not there yet, and I'll cover those in an upcoming slide. I've captured the ones, though, that capture kind of the vision I had for the language, and also I've captured the ones that might have changed the syntax or the feel of the language. So the additional nifty features, they're mostly conveniences. No IDE plugin. I plan on starting that in March, a Visual Studio plugin. And I don't have an interactive prompt, so if you want to experiment with code, just slap it in a text file, run it from the command line. February 2008, I'm leaving stealth mode. So Cobra's been around for a couple years. Nobody's heard of it. That's because I don't announce it anywhere. I didn't want a bunch of users sending me death threats when I changed the syntax and broke all their code. And I wanted to be able to evolve it rapidly. And I've been able to do that. And now that it's stabilized and it's more mature, I'm getting out of stealth mode. So here I am presenting it. I'm going to be open sourcing the compiler in February. Some bits of the compiler had an older style of Cobra, and I didn't want people to see that and think that's what the current style of coding in Cobra was. So I'll be adding the usual things: discussion forums, wiki, issue tracker. That'll all be on the same website, cobralanguage.com. So some commercial ideas, right? In 2007, I actually went full-time on Cobra. And I just paid my bills with my savings. I worked on Cobra all day. I played poker all night. And it was a lot of fun. I had a good time in 2007. In 2008, I've got to come back to contracting, paying the rent. So I'll be working on Cobra part-time. But then the question is, well, could I ever get back to getting full-time on Cobra? So, one idea is to have a visual Cobra. Take Visual Studio 2008, become an integration partner, and put that out as a product. Of course, you might do a book, website ads, or you might get sponsored by Microsoft or Novell to implement this wonderful productive language. Future features. So the context here is I want it to be the best, most productive, high-level, general-purpose language. I mean, that's why I went to Objective-C, and that's why I left Objective-C to go to Java. And then I was like, whoops, that's wrong. And then I went to Python, So that's what I'm reaching for. So I have some catching up to do, like Lincoln Friends. But if you're generating C#, how easy is that? It's a lot easier than if you had to code it up from scratch. Want language-level regular expression support because it's much easier to use regexes if they're directly in there than if it's a library. Built-in set, mix-ins and traits, DLR integration. So Cobra has support for dynamic binding, but it just uses regular .NET reflection for that. It does not yet use DLR, so you could not leverage a Iron Python or Iron Ruby object, for example. More future features. Units of measurement, feet and meters. That way, if one engineer is in feet and the other guy's in meters, your spacecraft doesn't crash on Mars, losing, tens of millions of dollars, which has actually happened. Maybe you need NASA as a sponsor. There you go. I'd like to have this. I'd like to be able to say for some methods, I don't care what the type is, but I do care that it has a name. And then I would like the compiler to tell me when I screw up and I call foo with something that doesn't have a name, instead of having to wait all the way to runtime to find that out. So compile time analysis of contracts. I am supportive of multiple backends, JVM, Objective-C, LLVM. I doubt that I will directly implement those, but I will certainly assist with code refactoring, technical support, that type of thing. The far future, there's a lot of interesting topics: parallel programming, futures, lazy arguments, macros. The .NET people figured out a lot of stuff for me. They figured out LINQ. They figured out generics. So by the time I get to the stuff, maybe they'll have these things already figured out, and it'll just be a matter of doing the types of things I've already done. And, wow, I actually got through it pretty quick. So there's a website. There's a more extensive document about why I built it. There's a more detailed comparison with Python. I'd like to make one for C# one day, but I just keep not getting around to it. Sample programs and so on. There's a blog, and there's my email address if you'd like to get in touch with me. And I know there are questions.
You have thing responds to get name as string. I just wonder if you could get your it's much closer to the end in your more future. There we go. Yeah.
Yeah.
Could you do some kind of code analysis where you automatically either insert or suggest contracts where you notice that it's a dynamic thing, but you notice that my method uses a name, calls get name, and so you automatically say, hey, this needs to have a contract there to guarantee that your method doesn't fail at runtime?
I think you could do that, and I don't know if it'd be more appropriate maybe to do it in the IDE so that you write def foo thing, you do your whole body, and when you're done and you go on to the next method, it inserts the contract, and you say OK or cancel. But yeah, definitely.
So on this part of your talk,
you preempted me. All right. I just had a quick question. With it being self-hosted, what would you do if you lost all of the Cobra binaries that you had, and then you're left with code that you couldn't compile to compile Cobra anymore?
Well, first, it'll never happen because of multiple offsite backups.
Okay.
But on top of that, the Cobra code is straightforward enough that if you had to, you could re-implement it in C# or Python using that Cobra code as your blueprint.
Okay. I was just curious, because that would have concerned me.
Yeah, no, multiple offsite backups. And actually, if you check Cobra out of Subversion, which is not public yet, but it will be within a month, you actually get a snapshot directory that has a binary in it, cobra.exe. And that's what you use to compile the source code. And then every once in a while, I take a snapshot and I push it in there and I check it in, and that becomes the newest snapshot. It actually works pretty smooth.
So I missed part of the talk. My apologies, but it looks like basically it's a statically typed Python approximately. Is what it looks like to me, or did I miss something?
At the inside methods, it feels very much like Python, but at the high level of class declarations, it really maps almost directly onto C#. Not only because I translate to C#, but because the concepts are pretty much one-to-one. This will come through in C# as being typed as object. It's kind of like degrade gracefully. So if a C# programmer looks at this foo method, the type for the thing argument is going to be object. But Cobra knows when it's generating the code inside here that it's dynamic, and it will use system.reflection to do all of the method binding.
Interesting. Do you have any benchmarks or proof characteristics that you sort of measured so far against something like IronPython?
I know it should be faster in IronPython because it translates to C#, and the translation's pretty close, but I haven't done the benchmarks yet. It should be almost the same factor between C# and IronPython.
You mentioned it, being somewhat similar to Python with a lot of C# concepts. How would you say it compares to the language Boo, which I know, is built along similar lines? Are you familiar with that?
Yeah, I'm familiar with Boo. I explored Boo in 2005. I even contributed one of the patches to it. So at the time that I was working on Boo, they didn't have support for generics, and I was putting some ideas out on the list about improving this or improving that, but not really getting a lot of traction with anybody. And it's not convenient or practical to have a language on .NET that doesn't do generics. Eventually, I got so impatient, I actually left Boo, and I went on to build Cobra. A lot of the differences between the two languages are emphasis. So Boo's big emphasis is being extensible and having macros, and other things like contracts and generics are behind. Cobra's almost the inverse of that. I don't have macros or compiler or extensible pipelines, but I've put a lot of time into making sure the contracts and generics are right. So it's a matter of different emphasis. They're both free. They're both open source projects. You can try both and see what you prefer.
Thank you.